Okay, we are entering our final lesson, lesson 34, in our math book, and we are going to be discussing lines of symmetry. And I went ahead and pulled out the family letter because I thought that this was a good one to give some examples of lines of symmetry. And I'm on page 743. So it says that you can find symmetrical shapes in real life in both natural and man-made objects. Now, a line of symmetry is a line that divides a shape into two mirror images. So a line of symmetry is going to be that line that divides the shape. So we see the butterfly, even its coloring patterns are symmetrical or identical. So if we were to fold that butterfly in half, it would fold perfectly as a mirror image. And this window pane also has a line of symmetry going straight through it right here. So we can divide objects into horizontal lines of symmetry and vertical lines of symmetry. And then sometimes, like on this X example here, we can have kind of diagonal lines of symmetry. And that would look like this on this X, where if I folded this point here, it would fold on top of this point and this one and this one. So one thing I want to point out though really quickly is about a rectangle. So I'm going to use this paper as an example. And if this paper was completely white, and we're just going to pretend that these little frayed marks here don't really count, but I would be able to fold this paper in half this way, right? And it would be a mirror image if it was a plain white piece of paper. So this would be folding it with a vertical crease in the middle. And then if I fold the top to the bottom, I'm going to create a horizontal crease here. Now, here's where some people get confused on a rectangle. You cannot go corner to corner or create a diagonal line of symmetry, because you see what happens. I have a lot of overlap here. And if I were to flip it over, I would have a lot of overlap right here as well. So this rectangle only has two lines of symmetry, one being the vertical and the second one being the horizontal line of symmetry. So now we're going to move on to today's lesson. So each of the shapes below has a dashed line drawn across it. Imagine folding each shape along the dashed line. If the two parts would fit exactly on top of each other, when the shape was folded, draw a star on the shape. So if they fit perfectly, kind of like how I did that rectangle for you guys. So I know a square and rectangle, if the top is folded down to the bottom, that definitely works. This triangle, it looks as though those would close up. Now here we have my rectangle. So if I were to fold this, remember this corner would end up being somewhere right here. And then this corner, if I were to perfectly fold it this way, would be over here. So this is not gonna work as a line of symmetry. And circles are really, really unique. As long as you draw a line straight through the middle, and we'll call this the middle right here, it has actually an infinite number, meaning there's so many different possibilities of line of symmetry on a circle. We could just keep drawing all those lines of symmetry as long as we're going through the very middle point. And now how about this one? Here's a triangle, and we see that it has three sides, but they look like they're different. And so if I were to fold this angle over, I don't think that it would quite match up right there on this angle. So that one is not. Oh, I forgot to put a star on our actual circle. So of these objects, if we were to fold them, the three of them are definitely going to have lines of symmetry. Okay. So when you can fold a shape on a line and the parts line up with each other, the line is called a line of symmetry. Remember, that's a mirror image. Some shapes have a line of symmetry and other shapes do not. Shapes can also have more than one line of symmetry. All the lines of symmetry for a square are shown on the square to the right. The lines of symmetry all pass through the center point of the square. How many lines of symmetry does a square have? Well, we have one here, that's the vertical, the horizontal. We have a diagonal and another diagonal. So there's actually 4 lines of symmetry on this object, this square. So squares will always have 4 lines of symmetry because I could fold this corner and it will match up perfectly with this corner, this top to this top, and this side to this side. Can you draw a line on the scaling triangle so the parts fit exactly on top of each other when folded? How many lines of symmetry does the triangle have? Well, we would have to start here at the vertex of this obtuse angle, and I'm trying to see if I'm just gonna draw this line and see, and I can already tell because this angle is even smaller than this angle here that there's not gonna be any lines of symmetry on this object. Can you draw at least 1 line of symmetry on each quadrilateral at the right and explain? Well, I know a rectangle has 2 lines. Oops, sorry, I drew that poorly. But if I were to look at this object here, I cannot find any way, even if I went diagonal, that if it would be folded, it would match up. So let me just draw a vertical line of symmetry. We can tell that that is not going to match that side. Let me draw a horizontal line. And that top, if I were to flip it down, will not match that one. So then this one is a big no, we can't. Okay, so after that short introductory lesson, you're going to be ready to work on page 747 and 748.